Okay, we continue with polynomials. Here we've got, we're still talking about multiplication of polynomials. We were talking about, the title up there is polynomials. This is the third one, so let's call it C. The last thing that we did was binomial times binomial. Let me just show you what it was. The multiplication that we did it already, so we don't have to do it again. But this is what it looked like. It was problem number 6. You have it on last video. 5y squared minus 6x times 2y squared plus 3x. Previous video. Okay, now we're going to problem number 7, which all looks very similar. It's a binomial. This was a binomial times a binomial, right? Binomial times a binomial. And so is the next one. Here's what it looks like, but there's going to be something very different about it. Just bear with me just for a second, just a minute or two. 2x plus 5 times 2x minus 5, binomial times binomial, 2 terms times 2 terms. We're expecting 4 terms here, just like we did before. If you go back to number 6, you'll see that we produced 4 terms and then it turned into trinomial. Let's see what happens with this problem. Again, it's FOIL, binomial times binomial, right? The binomial works both ways. This is binomial times binomial, so was this. Both of them were. Okay, well, what happens here? 2x times 2x, first times first is 4x squared. That's fine. 2x times minus 5, outside times outside is negative 10x. Inside times inside is positive 10x. And last times last is minus 25. Look what happens to the middle, the two middle. The two middle cancel each other out. One is minus and one is plus. Other than that, they're exactly the same. That means they cancel each other out. They turn into 0, nothing. And therefore, what have you left at the end of the day? Not 3 terms, not a trinomial like we usually get, but just a binomial. And this is it, 4x squared minus 25. That's a special case. This has a special name, and I don't try to harp on vocabulary if I don't have to, but this has got a very important name. They're called the conjugates of each other. That is the vocabulary word. Conjugate of each other. 2x plus 5 is the conjugate of 2x minus 5, and 2x minus 5 is the conjugate of 2x plus 5. You can see why, but let me explain. They both have 2x. They both have a 5, but one has a plus in between and one has a minus. That means they are conjugate. They're exactly the same, except the one has a plus in between the 2 terms and the other has a minus in between the 2 terms. Then they are conjugates of each other, and they produce a special result when that happens. These were not conjugates of each other, and we just had a standard binomial times binomial and FOIL, and we got a trinomial as our answer. Okay, that is the story with multiplication of binomials. We go on. This is all in R5. Let me double check that. I apologize. R4 in your book. Now we're going to go on to. It's in the same place. It's in the same section. It's in R4. We go on to multiplication of radicals. We've already dealt with it a little bit, but now we're getting more into it. Let me show you what I mean. Let's first practice a couple of small ones and then move on to the bigger problems. Okay, so my title over here is multiplication of radicals. Okay? All right, so first some practice. Now let me move my paper up, and I believe we have enough on this paper for me to take care of my practice problems. Let's first try the following. Apologize, right over here. 3 square root of 5, that's a radical. We're back into radicals, for better or for worse. We're back into radicals. 3 square root of 5 times 2 square root of 3. Okay, let's first practice that one. I have 2 practice problems before we start the bigger ones. 3 times we do the normal number times the normal number, right? You won't have to find that in the math book, but I call this the normal number times the normal number, the one on the left of the radical. 3 times 2 is 6. And then the radical times the radical, 5 times 3 is 15, so it's square root of 15. The problem is over. These are practice problems. They're easy. They're not supposed to be hard. Here comes the second one, and it's going to be a little bit of a trick question. What if you have 3 square root of 5 times 2 square root of 5? It's a little bit of a trick question because you'll notice I'm doing something here. The 2 radicals match. So this is 3 times 2, which is 6. And then the square root of 5 times the square root of 5, you're going to tell me that it's 25. You're right. You can leave it that way. You have to say this square root of 25 is equal to 5. 6 times 5 is equal to 30, and the final answer is 30. But the shortcut, do this the short way. 3 times 2 is 6. And if these 2 radicals match and they're multiplying each other, you know that square root of 5 times square root of 5 is going to turn into 5 itself. And 6 times 5 is 30. Take the short way. This is really the answer, but take the short way. Don't go the long way. Take the short way. The square root of, no matter what number you put in there, 513, times the square root of 513 is equal to 513. The square root of x to the 6th times the square root of x to the 6th is x to the 6th. Let me put that up here. The square root of x to the 6th times the square root of x to the 6th is going to be x to the 6th. The square root of blank times the square root of blank is always going to be equal to blank without the square root sign. Square root of 513 times the square root of 513 is 513. This is extremely important to remember, and we're going to need this for our next phase here. I actually can keep going on this video. All I need to do is get myself a blank page. Okay, here we go. Blank page. Hopefully it's coming up. There we go. All right, so now let me show you a harder problem that we have to deal with. We have pretty much no choice. Let's call it problem number 1. And it is because we're multiplying radicals now, and we're doing a little bit of a harder problem in multiplication of radicals. 3 square root of 5 times what? Times a whole deal here. 2 square root of 5, that's one term. Next term, 4 square root of 2. And next term, this one is actually going to turn out to be easy, the last term, plus 1. It's a regular number. Okay, what do? We've got to multiply. The task at hand here is to multiply the 3 square root of 5 times the first one, times the second one, and times the third one, and we'll be finished. We'll be done. It'll be a case of 1 monomial times 3 times the trinomial. How many terms are we expecting on line number 2? We're expecting 3 terms. Okay, one at a time. 3 times 2 is 6. Square root of 5 times square root of 5 is 5. Don't worry, I can always go to the next step and clean this up. Let's not skip any steps. 3 square root of 5 times 4 square root of 2. 3 times 4 is 12. And square root of 5 times square root of 2 is square root of 10. And 3 square root of 5 times 1 is 3 square root of 5 times 3 square root of 5. Anything times 1 is itself. 75 times 1 is 75. 3 square root of 5 times 1 is 3 square root of 5. 3 square root of 5. Okay, cleaning this up, this turns into a 30. This is the same old 12 square root of 10. And this is the same old 3 square root of 5. And this problem is over. This problem is done. Now, be careful. On an answer sheet. They may rearrange it. If you did this, you have the exact right answer. You are 100% correct. But on an answer sheet, they may decide, you know what? We'd rather have the 3 square root of 5 first, then the 12 square root of 10. That's the way we think things should be. And then the last should be the regular number plus 30. And that's what we put on the answer sheet as answer C. and you pick answer C. You check your scrap paper, and they exactly match. They're just rearranged. This can happen all semester with all sorts of type of problems where you have the exact right answer, but you didn't arrange it the same way they arranged it on the answer sheet, but you have the right answer. Just double check that they're actually the same. They actually match. Your answer actually matches. They all match, and you pick C, and that's the right answer. Be careful with those answer sheets when they rearrange it and they don't look exactly like you have on your scrap paper. Okay, that's a general truth that we got to be very careful about. Okay, now problem number 2. What about, and let me move this paper up here. Let me move the paper up, and I have enough room, I believe. Problem number 2. Here we go. What about 3 square, and this time 3 square root of x, now we're mixing in x's, right? Obviously we're getting a little bit more complicated, times 2 square root of x minus 7. Now let me go off on scrap paper for a second. Let me ask you a quick question. What is the square root of x times the square root of x? Answer, x. We talked about it before. The square root of 513 times the square root of 513 is x. The square root of x to the 6th power times the square root of x to the 6th power is x to the 6th power. The square root of x times the square root of x is going to be x itself. Okay, let's go back to our problem. 3 square root of x times 2 square root of x, that's going to be 6. 3 times 2 is 6. And square root of x times square root of x is going to be x. Right? This is a binomial times a binomial. So first times first, right? 2 terms, 2 terms. First term times first term. Outside times outside is 3 times negative 7, the regular number times the regular number, that's a normal number. So they take the normal number times the normal number, that's minus 21, square root of x. Right? This is not going away. Inside times inside. 5 times 2, 5, the normal number 5 times the normal number 2 is 10 square root of x. And finally, what about 5 times negative 7? It's minus 35. It's 2 regular numbers. It's cleanup time. 6x has no match. Minus 21 of these plus 10 of these is minus 11. It's an exact match, like terms. Minus 21 square root of x plus 10 square root of x is minus 11 square root of x. Minus 35 isn't going anywhere. And there's our final answer for problem number 2. And that's all there is to it for problem number 2. We've got one more to go, but I don't think that we're going to get it on this piece of paper. Maybe we have a chance for one more. No, so let's just end this video and do it on the next video. I don't want to take any chances of going over time.